So let us apply the Biot-Savart law due to a current carrying straight conductor. Here, the magnetic field due to infinite straight wire or conductor carrying steady current. So in this case, we have the conductor or the wire is straight and it extends up to infinity at its both of the ends. This means to say on the upper end it extends up to infinity and on the lower end it extends up to infinity. In practical case, we can consider that the length of the wire is very large as compared to the distance between wire and the observation point. We can consider it that way. So here the point P is observation point which is at distance small a from the wire. In that case, if we apply the Biot-Savart law, the derivation is given in the books. If we apply the Biot-Savart law, the value comes out to be is equal to mu naught upon 4 pi 2I upon A into n cap. Here n cap is the direction of magnetic field B, which is given by the right hand screw rule. What can we say that if I hold the wire straight in the right hand like this and the thumb gives the direction of current and coil the fingers towards the wire like this, then my all fingers gives the direction of magnetic field like this. If I hold this wire like this, the thumb gives the direction of the current and these fingers will give the direction of the magnetic lines of force. So the magnetic lines of force are circular rings around this straight wire and the direction is given like this. So the circular ring go on increasing in its diameter or radius as we move away from the wire. So this is the expression due to the conductor which is of infinite length. If the length is finite, in that case we can consider the wire like this. We have X point, we have Y point. Here we have observation point P, which is at distance A from this wire. Let us suppose that point P, X, P, Q is phi 1, angle Y, P, Q is phi 2. Then this expression is modified to B is equal to mu naught on 4 pi I upon A sine of phi 1 plus sine of phi 2 into n. The direction is similar as we have explained earlier. So on the basis of this expression, we can take an example here. Find the magnetic field at the center of wire. The wire is in the form of a sphere as shown in figure. Here we are given a sphere through which the current I is passing in this way and the length of the sphere is 2a. We have to find out the value of magnetic field at the center of the sphere. If we see the sphere in another way, we can consider that sphere is a combination of 4 straight wires, wire AB, BC, CD, DA. So the magnitude of magnetic field B at central point O will be equal for all these conductors. So if we find out the magnetic field at point O due to one conductor and multiply by 4, we can get the value of magnetic field. So let us suppose this conductor AB makes point E at the center of the conductor. If we join point E and O, as we know that the sphere, in case of the sphere, the diagonals divide each other at 90 degree. So this portion divides both of these angles into 45 degree and 45 degree. Now, if I apply the value of magnetic field mu naught upon 4 pi I upon A. A is the distance between point E and O. Here, the side of the sphere is 2A. This portion is A and this portion is also A as the property of sphere. So, I upon A sine of 45 degree plus sine of 45 degree. So, we know that sine 45 degree is 1 by root 2. So, here 1 by root 2 plus 1 by root 2. The result comes out to be mu naught upon 4 pi 2I upon root 2 into A. So, this is the magnetic field due to one straight conductor. If I multiply this field V with 4, I will get the value of total magnetic field due to whole of the sphere. So, the value of magnetic field is 4 into 2I is equal to 8I upon root 2A. This is the value of magnetic field due to straight conductor. Now this wire was straight. If this wire is in the form of a circle, then what will be the direction and value of the magnetic field B? We can discuss here.